Hello everyone. For this hackathon, we are presenting on a topic called data poisoning. So I'll explain the problem statement and then we'll go forward for the solution part. Okay, so the problem statement is actually many AI systems they get trained on something called poisonous data. So these are the datas, but these are actually very harmful for the model to get trained on, because once the model gets trained on these kind of datas, it behaves very, the model behaves abnormally. So basically, if for example I'll tell you something. Imagine if you are asking GPT and then about some medical something like heart related disease or something, and GPT gives you some fake data. Like, it will give you something very fake, and many people will believe that usually. So this should not happen, right? So for this, OpenAI, what OpenAI does is they hire manual people to purify the data, but we are doing this in a way which computers can recognize that the data is fake, so segregate it and give this for the human verification, like the fake data, and the clean data can directly train the model. Okay, so this was a problem and the solution overview. So what we are building is an encoder layer which which just analyzes the data, and then it segregates whether the data is fake or real, like that, like clean and poisonous. Okay, so we'll move on with the implementation part. What we have implemented, I'll show you that one. So I have an account in this, so I'll just go and sign in. Yeah, this is our platform. Okay, so now you have to import the dataset which you want to train. So by default we have trained this on something like diabetes dataset. So you can import any diabetes dataset here, and then you can check how many percent of the diabetes data is real and how many percent is not real. Okay, so I'll just import the diabetes. So this is a dataset which contains 910 clean and 90 poison datasets. Okay, so I'll just import this now. I'll open this thing. It's just processing and done. Now I will initialize stream. So what does this mean is, so we are just sending each row of our data set to the model through the model, and that will verify if that is proper or not. Like, each row it will verify. So each row is nothing but a each set of data of a particular patient or something. Okay, I'll just initialize stream now. Now you can see it is training. It has scanned 100 rows properly, and it is showing me 909 clean, 91 poison. So if you see properly here, our dataset contain 910 clean, 98 poison. Okay, so it has missed one, which is completely natural for AI models, because AI models are tend to behave like that. Like, a model should not be 100% clean. So if it is 100% clean, that is something called as overfitting. Like, your model is not taking the lost things and all. So this is a complete ML concept, so you can go through it. So the model should be somewhat of that kind. Like, it should not be 100% proper, like overfitting, and 100 not kind of underfitting. It should be in somewhat in the middle. So this is a perfect thing for that. And this is 909 clean data and 91 poison data. You can even you can download the data sets like clean and poison, and you have many formats here like CSV format data, JSON format data, Excel format, paraquet format. You can download that from here, and this is what you call the rank monitoring system. This is like a dashboard. So each in our system, in our platform, it's like for 10 rows we are considering them as one batch, and then we are verifying the model. So this the 1 4, these are like what you call the batches. Okay, so you can see the effective rank of each of the batches, how it was. And then this is what you call neural sentinel. Neural sentinel is nothing but this is a kind of a diagram which shows you like the visual representation of your data, like confidence, density, stability, integrity, and flow, and all. And these are the security logs, and this is semantic, geometric, and heuristic. And yeah, this much was this section. And you can see here feature density is there, model confidence is there, scan batches, drift probability is there. So more the drift, that means your data is more fake or something, like, how poison data. Here it is only 91 data. So it's like, if you compare with 1000, 91 is very small number, so it's telling 0.1774, like that. Okay, so now we'll go to a zone called, we'll go to this section, which is a personal zone. Okay, now this is a very famous thing, or this is the best thing about our platform. Like, why personal zone is useful, I'll just tell you. I'll give one small example. Okay, imagine you are an AI company, and you want to see whether the kind of, imagine you're a company which predicts something like heart related diseases or something using patient records. Okay, and first what you guys will do is you'll come to our platform and you will go to the personal zone. You will put your data set here, like your hard data set or something. Now as I'll show you the real implementation, you'll put the hard data set here. Wait, it should be here. Okay, I have one hard data set, I'll put it here, and I'll just train the model by this hard data set. Okay, it will train the model by itself. See, it is training, see. It's like the red line indicates the loss. This is the accuracy. So you are an AI company which predicts the heart diseases and all. You will just train this model now, and then when you get the further hard details, like imagine if you are an AI company, right? You'll keep on increasing the data sets. Like you'll put the further future data sets and all inside this, and you would like to train your model more so you can get higher accuracies or something with the changing nature and changing generations. Okay, because many things will change with generations, right? That one. So what you guys will do is you will first train the model. You will have the trained model. Okay, so I'll show the trained model here. uh, these are all the previous model which I trained. This is the recent model which I did. I mean, this now what we did. I'll go to overview section. So now imagine you guys have trained models there, and now you have a complete model file in this here. This is a model file. Okay, this is a model file, this one. I'll just use a hard data set. I have a hard data set here which consists of 100% fake data. Okay, so I have used the custom model which we had made now, hard model, and now I will initialize the stream. Okay, now if you see properly, it has trained and it is telling me 500% poison data. So it's like it consisted of 500 rows, and it is showing me that all of them were poison, which is very true, because in this also we have said that it is fake data. We have generated it. So it is showing, and you can download again the same thing, clean and poison data of any format. Okay, and this is a rank monitor, what you call this, and it is showing it in red color because most of the data are poison. So it's obvious it's like no use. Semantic geometric heuristic, this is the, I mean, analysis score or something. And now so this is why personal zone is like, this is a gem in our entire project. Okay, you can train your own model here, and then you can use that for predicting your future this thing. So now we will move to the data lab. In data lab, it's like, how you use a natural language processing things here. Imagine you have a small data. I'll tell this like the weight, WEI, is 1000 kg, which is really impossible to have, right? 1000 kg weight is like really impossible for someone to have. So if I tell this that if imagine if you can train the 1000 kg weight to the AI model, and then if you ask AI model that the person is 1000 kg, it will tell yes, the person is 1000 kg, it will tell like that. But it should not happen, right? So this is our thing for that. When you tell the weight is 1000 kg, it will tell that is an anomaly. So because this is a poison data, don't put it in model like that, just telling me. Okay, this is what data lab consists of. And the next thing is your security events. Security event consists of the entire log of what we have did till now. There is like poison data is 33,425. Means like I had used this for I mean the initial use and all, so it is showing like that. 5 critical threats were there. Okay, accuracy and the things which I had done now, like see this heart fake I did now, right? So clean poison like that is showing. And now we'll move to the last section, that is called the system settings. Okay, in this we can make the system configurations and all. So for example, you can you can make your model as default model. So imagine if you are a AI company based on some hard data sets or something, you can just make your hard data sets as a default model. And if you go here, you just have to put this one. You just have to put the drop your file here and then just initialize the stream. This will be a hard one itself. Instead of taking the diabetes one, we'll give that to the okay. And the next thing is strict defense mode. Now I'll explain what strict defense mode is. Okay, imagine you are a company which has connected this application to your AI model. Okay, so now what happens is when your AI model is getting the data, it will detect poison data. Okay, so poison data should be halted, right, from going to the AI model. So you can just halt the system here. I mean, once you get the poison data, you just stop the system and tell them don't send anything. That's the thing. And then the last thing is simulation speed. I'll show you the real-time example of this. A very nice feature, and this will be considered as one of the business benchmark of our entire system. That is, imagine if you are in turbo mode. Okay, if I'll show you the example with slow mode. If I'm in slow mode now, and if I go to overview and verify a model, imagine I'm going here, like I'll go to the there data. I'll go here. I'll put no, I'll put this file. Okay, I'll put this folder file. Okay, and now I'll initialize the stream. Now we can see how slow it is getting trained. If you see properly, how slow it is getting. See 1, 2, 3, 4. So it is processing a batch very slowly. Okay. So now if I go here and if I change to turbo, okay, and now I'll come here and drop this here. I'll just go like I'll just put it here, put this here, initialize the stream. Okay, now we can see how fast it's getting trained. I mean, within 2 seconds it got scanned. Okay, so this is what this is. I mean, this is what this simulation speed is. So you can put a, I mean, something like business model. So you can put limits for this. If you want turbo mode, then you have to pay this much, like that. Fast mode, also normal mode, slow mode, all these are available in our systems. And you can even see the models which you had trained. See the models which you had trained here. Okay, you can just select any one and do that. Okay, these are the overviews, personal lab, data lab, security events and settings. So this was our project. I hope you like this project, and thanks for letting us present this topic for this hackathon, and thank you very much. That's it.